Find the derivative of y equals the tangent of 2x over 2x to the fourth quantity cubed. So y here is a cube power of an entire expression which itself is a quotient, tangent of 2x over 2x to the fourth, and then the entire thing is cubed, which means the cubed is the outermost function, and we start with it for the derivative. But then when we take the chain rule, the derivative of the inside is a quotient, and the quotient rule will be used for the derivative of the inside. So our overall derivative y prime, or dy dx, will be, start with the power rule, we'll bring that power down, we'll leave the inside alone, so tangent of 2x divided by 2x to the fourth, subtract 1 from the power, it'll be to a power of 2. And now we multiply by the derivative of the inside, which is a quotient, and therefore we'll make use of the quotient rule. Here's the inside of the power. We're taking the derivative of that. We start with the derivative of the numerator of that. Well, the derivative of tangent is secant squared, so we'll have secant squared of 2x times the derivative of the 2x to complete the chain rule, so times 2. Derivative of the numerator times the denominator left alone, 2x to the fourth, minus the numerator left alone, so tangent of 2x, times the derivative of the denominator, derivative of 2x to the fourth, bring the 4 down, 8x, subtract 1 from it, 8x cubed. All of this divided by the denominator squared, so 2x to the fourth quantity squared. And all of these are being multiplied with each other, so I'll put square brackets around that for now. So y prime, or dy dx, will be 3 times, now we're going to break this quotient squared into the numerator squared and the denominator squared. So we'll have the tangent of 2x squared. We can call it that tan squared of 2x if we want. And we will also have 2x to the fourth squared. In the square brackets, let's put these out front. We have a 2 times a 2, that's a 4. And we have an x to the fourth, and then we have a secant squared of 2x. And then just the same, I'll put this out front, so minus 8x cubed tangent of 2x. All of that is divided by 2x to the fourth and then quantity squared. Well, you can square each of those. 2 squared is a 4, and x to the fourth squared, you multiply the exponents. 4 times a 2 is an 8, so it's actually x to the 8. Now we have the numerators all multiplying each other. So I have a 3, I have a tangent squared, I'll just call it tangent squared now, of 2x. And I have the entire expression of 4x to the fourth secant squared 2x minus 8x cubed tangent of 2x. And I can multiply all the denominators. Now in the denominator I have a 2x to the fourth quantity squared. Again, I can square each of those. That'll be a 4, and then once again x to the 4 times 2, which is x to the 8, times the other denominator, which is already a 4x to the 8. And we can multiply those together. Now in our next step, we're going to factor the numerator, because the numerator, what's in the parentheses, has a common factor of, it looks like we can take out a 4, and it looks like we can take out a power of x as well. Now we can do this one thing at a time, or all at the same time. But we have that 3 tangent squared of 2x. And we have a factor of 4 that can come out of here. And we have an x to the, well, let's see, x to the fourth power here and x cubed here, the lower of the two powers. X cubed is what you'll be able to factor. If we take out a 4, that's going to be left with a 1, and that'll become a 2. And if we take on x cubed, we'll take out 3 of the 4 here, and we'll take out all of these. So we should have that left. It looks like we'll have x secant squared of 2x minus 2 tangent of 2x. So that will give me x secant squared of 2x, and then minus a 2 tangent of 2x. All this is divided by, in the denominator, let's multiply. 4 times 4 is a 16, and x to the 8 times x to the 8 is x to the 16. You add the exponents in that case. Now everything in the numerator is multiplied, so we can reduce things in the numerator with things in the denominator. See, there's a 4 in the numerator. We can cancel that down with the 16 down here and leave a 4 in the denominator. And then there's an x to 3 in the numerator and an x to the 16 in the denominator. We can take out all 3 of these to take out 3 of these. By subtraction, 16 minus 3 is 13. There's 13 left over in the denominator. At that point, it should be fully factored and fully simplified. So we have 3 tangent squared of 2x times x secant squared of 2x minus 2 tangent of 2x. All of this divided by what's left over in the denominator, which is 4x to the 13. There's our derivative, y prime, or dy dx.